Today we are going to do the composition of functions. Now before we do that, we are just going to do mention some quick addition and subtraction facts. Okay, now let's look at this thing on page 240. As you can see, well, what does it mean to add functions? Well, you just add them up, same as subtraction, multiplication, and division. So when you see symbols like this, it just means do, well, what you think you're supposed to do. That's all. So as an example, let's consider example 1, where it says we have f of g, f of x is x minus 1, g of x is x squared minus 1, and we're supposed to figure out what is g minus f of x. Well, you just subtract those two things, okay, as we see. So g minus f of x is simply let's subtract them, and it becomes something. You can factor it or not, so that's the answer. Similarly, what is g over f? G over f is, well, you take the 1g, which is x squared minus 1, and divide it by x minus 1. In this case, you can factor it, and you have to specify, as always, the denominator is not 0. That is, x cannot be 1. So otherwise, you can cancel it, and then, well, you get x plus 1 as the result. It happened to be able to cancel it, but even if you can't, that makes no difference. That's what the functions of addition, subtraction, multiplication, division are. They are just, well, what do you think they are, okay? And so that's that. Now, so let's go to the next page. I'm on page 241. Let's see, page 241, where we talk about the essence of this section, the composition of functions. What happens when you compose functions together, which is called f of g of x. Okay, it's sometimes written with a circle like that, and f of g of x, or sometimes just written as parentheses. The parentheses notation is better because it shows you exactly what we're supposed to do. That is, we're going to stuff g into the input of f. Now let's look down and see an example of that. Let's say f of x is equal to x squared. I will write that down here. So f of x in this example, which doesn't have a number to it, f of x equal to, let's say, x squared. Okay, and then g of x is equal to x plus, g of x equals x plus 2. Okay, two very simple, straightforward functions. And for what we're going to calculate here, what is f of g of x? So f of g of x. What does that mean? That means we're going to stuff the entire g of x, which is x plus 2, right inside where x used to be. In other words, we're going to do this. F of x plus 2. See, I stuffed the entire x plus 2 in here. Okay, and what are we supposed to do with that? What does that mean? It means we're going to take everything in here and do what it says. The function f says that you take what was input and square it. Okay, so we're going to do exactly that. So the input now is a big long thing, x plus 2, but we don't care. We're just going to blindly follow the instruction, which says square whatever that you got stuck in there, which is x plus 2 squared. And that is the answer. And you can multiply this out, which becomes x squared plus 4x plus 4, or we can just leave it. Either one is fine. So then the other way, well, you think, well, if we can do that, what about the other way? Okay, what about if we have g of f of x? What would that be? Now, we can do that exactly the same way we do this. So g of f of x, it means we stuff f of x right inside where g used to be. Okay, so that is equal to g of let's see, x squared, because f of x equal to x squared. Okay, and then the next step is you follow the instructions. What does g do? Well, g will take the input and add 2 to it. As a simple function, that's all it does. So that equals to take the input, which in this case is x squared, and then add 2 to it. That's it. That is g of f of x. Okay, And well, that part is a little higher. So g of x equal to g of f of x equal to this thing, whereas f of g of x equal to that thing. As you notice, those two things are not necessarily the same. And in this case, that is not the same as this, because this expands into x squared plus 4x plus 4. Okay, so that concludes the composition of functions concept. Basically, what you do is in composition functions, you imagine stuffing one function into the input of the other function. Okay, and it doesn't matter how fat it is, you can stuff it all in and then use this function to do whatever it's supposed to do to it, and then come out with the answer. So let's flip the page. Now we're on page 242, and let's look at example 2. Page 242. Example 2 is we're trying to decide if this thing is commutative. What's commutative? Oh, that is to find out if they just, by that word, they just mean that to figure out if f of g, okay, that is, and g of f, right here, are the same. As we have mentioned earlier, they need not be, okay? If you stuff them in a different order, the stuff might come out looking quite different. So we're going to look at this example of example 2. So let me write this down. So here's our function f and g. Okay, they're somewhat similar, but otherwise they're two different functions. First, let's calculate what f of g is. F of g of x. As I mentioned before, we are going to stuff the entire g of x inside f's input. So that is equal to f of 3 minus x. Okay, and then so once we've done that, we are going to do to this whole thing exactly what it says here, which is the function f says we take the input, multiply by 2, and then plus 1. So we'll take the input, which is 3 minus x, and then we multiply by 2, and then we plus 1. And that is f of g of x. And we can simplify this thing a little bit. That will be 6 plus 1 is 7 minus 2x, okay? Which is what the book says. So that's correct. Now next, let's do, so I'm not going to finish writing that, but you should do that, of course, in your homework. And when you redo this example. Now the next thing we do is g of f of x, and we do it by the same principle, which is okay, so we write down, we're going to calculate what is g of f of x, which is 2x plus 1. And then we have, what is g of 2x plus 1? That is equal to 3 minus, according to g, you take the input and just take 3 minus the input. So we'll write down 3 minus input. Be sure to write parentheses here, especially if you're doing minus, because you're minusing the entire input. The input is 2x plus 1, and that's that. And this happens to be 3 minus 1 is 2, so it's like 2 minus 2x. That's correct, okay? As your book shows, minus 2x plus 2, same thing. So that's g of x, and again, as you can see, that they're not the same thing. So that's problem 2. Example 2. Next, let's, we are going to skip over example 3 and 4 because they are, well, not very exciting. And then let's move on to example 5. The example 5 is when you evaluate the function from a table alone instead of something like this. And well, whether you evaluate it from a table or from an equation or expression like this, is the same thing. We do exactly the same deal. Now in example 5, the first thing we're going to evaluate, okay, this is example 5. And what page is, I should write down the page number, which is on page, we're now on page 243, okay? All right, so example 5, we're supposed to calculate f of g of 3. So we're going to evaluate something like this from the inside. That is, first we need to figure out what g of 3 is, but from the chart. So looking at the chart, when the question is, when x is 3, what's g? G of x. So we're doing this one. So x is 3, and you look down, when x is 3, look across, it says g equal to 2. All right, so we write that down. So this equal to f of 2, okay? Why? Because g of 3 is 2, says the chart, if I didn't mess it up, okay? So, and then f of 2, then we look at the chart again, ask ourselves, what is the value of f of x when x is 2? So when you stare at this thing, when x is 2, you look at the f column, it says f is equal to 8. So we are going to do that. And so that f of 2 equals 8. And that should be the answer. And that is what the book says. Okay? And then g of f is works the same way. But we are always going to do, what is it, 3. Okay, we're going to start figuring out what this is first, right? What's on the inside. And then we can evaluate what its value is. So what is f of 3? Looking at the chart again, f of 3 equals to... if you look at 3, it's 3 is what I got. Okay, it's equal to g of 3. And next, let's figure out what g of 3 is. Well, I got 2 based on looking at the chart. So f of 3 end up being 3 here. And then you calculate g of 3, which being 2. So let's see. Yep, that is what the book says as well. So that's example 5. Please be sure to do that as part of your homework. I have your homework written down. Skip examples 3 and 4 if you want. Of course, you can always just do it by yourself anyway. It is your choice. And I don't think they're really worth mentioning, which is why I'm not mentioning it. Next, let's go down a couple of pages. Now, one page. Now I'm on page 244, where I'm looking at example 6. We are supposed to figure out f of g of 1, okay? This is example 6. We need to calculate f of g of, f of g of 1. Of 1. All right. So what is f of g of 1 is that if you look at the chart, that equals to, first we need to figure out what g of 1 is. Right. So here are two charts. The first one is the f function. No, the first one is the g function. So g of 1 is, you look up, is 3. Okay, so so g of 1 equal to 3, which I write it in here. Okay, and then f of 3, then we look at the f chart, is on the other side. Look for f of 3 over here. Okay, what does it get? I get 6, right? So then the answer should be 6. So f of g of 1, let's turn to the next page. F of g of 1 is 6. Is that all we need to do? I guess. Okay, so that's that. And so please do this example as part of your homework. You will be doing more of this in the actual homework as well. So basically we're doing from a graph the same thing we're doing from the formula. We figure out what this thing is, whatever is on the inside, and then we calculate the whole deal. And so we're doing in composite functions, we're just doing 2 evaluations. And then next, example 7. Okay, composite function as evaluate. I'm looking at example 7 now, page 246. So example 7 on page 246, we have f of t is t squared minus t, h of x is 3x plus 2, and then we're supposed to figure out f of h of 1. Now there are 2 different variables here, but that means nothing to us, okay? We will do it exactly like we're told. First, what is h of 1? If you plug 1 in in the input position, which is x, then h of 1 will be 3 plus 2 is 5. So we'll write that down. That equals f of 5, okay? And then it says the f is defined as you take the input and then square and minus itself. So 5 squared minus 5, that's like 20, okay? So that would be the answer. So that equals to 20, and as you can see, that is the right answer. So that is always great. And next, let's consider the domain of some composite function. The domain is something that we have to consider where the function comes from. So it will be restricted by both functions. If either function has a restriction, then the domain will be restricted in that way. So let's look at it. Okay, here's on the following page, page 247. So let me erase the board. Now in problem 8, we have f of x equal to a fraction. You know what that means? The denominator can't be 0, so the domain is going to be limited. And then g of x is another fraction, more limitations. So the only thing we're concerned about in this case is when is the denominator 0. The first time, well, for what? For the f of g. Okay, so we are only doing f of g in this case. So we're doing f of g, and remember, that just means f of is written the same as this one, f of g of x. That is, if you stuff g into the input of f, and you see what value of x will make this whole thing collapse because it's dividing by 0, and then we avoid those points. Now, first, of course, is that 3x minus 2 better not be 0. Okay, so that's the first condition, is 3x minus 2 is not 0, or put it another way is x is not equal to 2 over 3. If you move 2 over, become positive, and then divide by 3. Okay, so that's the first answer. The second answer, however, is once you plug this thing into f, so we have f of g of x, okay, and that equal to something in here. That would be that cannot have a denominator that equal to 0 either. So let's plug it in and see what happens. That equals to 5 over, okay, I'll stick the entire g of x into this thing right here. So g of x is right here, 4 over 3x minus 2. See, I put the entire g of x where x is in f. So it's right down here, see? And then this minus 1, in this situation, this thing is the denominator, and it cannot be 0. So let's write that down here. So 4 over this 3x minus 2 minus 1, this cannot be 0. Okay? So whatever value that makes this thing 0 is unacceptable. And so we need to figure out what that might be. When does this thing equal to 0? So we'll solve for that. Okay? And so let's write down this equal to 0 to find out the offending number or value for x. So when does this equal to 0? We will solve this thing by our fraction. This is done in the last section of chapter 1, I believe. Okay, so let's do that. So common denominator, okay, minus 2 minus x minus 2, 3x minus 2. We put everything under the common denominator, and this is a 4. Okay, now you notice that when you cancel this out, you get this thing back. That is just 1, and minus 1, and this is that. All right, so everything's good. And so now that we have the common denominator, we can do this. Okay, so 4 minus 3x minus 2 is going to be equal to 0. Now this part is, where's my minus? Right here. Now this part is important that you put this part in parentheses, okay? Because we're subtracting by this whole thing, not just the first term. Oh, I shouldn't have a minus sign here. Yeah, okay, so see, this looks okay. So we're subtracting by the entire 3x minus 2. And therefore, it is important to put parentheses there, because if you don't, you're definitely going to get the wrong answer. So now we have this done properly, so that becomes, now let's do the math. This is 4, okay, minus minus becomes plus, that's 6. And then minus plus becomes minus, 6 minus 3x equal to 0. And let's put the x to the other side. So then x equal to 6 over 3, which is 2. Okay, and so x equal to 2 is the other unacceptable position, because if x is 2, then this thing equal to 0, and which makes the denominator 0, which is not acceptable. So the two unacceptable parts is, first, x cannot be 2/3, and second, x cannot be 0, because both situations will force the denominator at some point to be 0, which is not acceptable. So, so those are not in the domains. Am I right? Yeah. So that is the answer. The answer is x is not 2/3 and x is not 2. Now that can be rewritten, okay, as well. This can be rewritten as your answer then if you write it the long way, that is from minus infinity to 2/3, okay? Then from 2/3 to 2, and then from 2 to positive infinity. In other words, this whole description is the whole number line missing 2/3 and 2, like this says. All right, so that is example 8. Please do this as part of your homework. Okay, next let's look at example 9, which is a similar situation, but now we have radicals. Now when it comes to this, which is the square root. For radicals, as always, the requirement, it doesn't mind being 0, but it does not like to be negative, okay? Right now, we're forgetting the fact that we learned about complex numbers and just focus on real numbers only, which means anything under the radical cannot be negative because we cannot take the square root of any negative number in the real number system. We have to go complex, and we don't want to do that right now, okay? So that is, so that's example 9, so let's do that. Let me write it down. So let's look at example 9 on page 247, where f of x is square root of x plus 2, and g of x is the square root of 3 minus x. Now, anytime we square root, then let's have the conditions out. So let's first consider, because g of x is what we consider first, so then the first condition is 3 minus x has to be bigger than or equal to 0. Equal to 0 is okay, negative is not, okay? Which when you solve this inequality by pushing x to the other side, so then that means 3 is bigger than or equal to x, or x is smaller than or equal to 3. That would be one condition. But that's not good enough yet. Now next we need to stuff this thing inside f's input and see what happens, okay? So let's do that. So then if we put g of x in here, that would be f of square root of 3 minus x. So we are going to follow the f instructions, okay? F of any input is to do this to it. So that equal to the square root of, we'll write this thing right where x is. So that becomes 3 minus x, and take the square root, okay, right here, into f of x. And we put 3 minus x right into the spot of x. And so we follow the instructions. Plus 2. All right, so that is the whole deal. I put parentheses on it, but it's not necessary. But anyway, so f of the input is the input plus 2, see? And then take the square root of it, which means whatever is in the under the square root sign here has to be bigger than or equal to 0. Now, at this point, we lucked out, however, because the square root of anything is always positive, right? And then plus 2 is still positive. So this whole thing will always be positive or equal to 0. It probably never be even equal to 0 because we're adding 2. So, and this is a positive or 0 value. So this will always work. So the only condition we need for this problem is x is less than or equal to 3. And that should be the answer. Let's see. Yeah, so then the answer is a domain then goes from negative infinity all the way up to 3 with brackets, which means 3 is included because there's an equal sign in here. So any x that's 3 or less is acceptable as the domain. So that's example 9. Now in the case where this thing is, let's say it says a minus, then you will have to solve this equation for this whole thing being a positive. One is a positive, and by solving the inequality. But we don't have to do that right now because the whole thing is positive inside already. Okay, so that's that. And let's look at the next problem. So next, let's look at example 10 on page 248, where we have f(x) equal to that thing, and all we are supposed to do is to break this thing up into 2 fractions. Okay, so just by looking at it, let's call whatever's inside something else, like let's call it, I don't know, h or something. The book wants to call it h, so we shall call it h. If we call what's on the inside h of x, then this is 5 minus x squared. In that case, then f of x would be equal to, so then f of x is then equal to the square root of something. Well, we'll make up another name, okay? So then g of x, we'll call it the square root of something, because that's what g of x what the next part does. G of x, we'll call it square root of x in such a way that then f of x then is f of x then will be equal to the g of h. See, because if you combine g of h of x, I should write that down carefully. G of h of x, because if you plug the h, okay, inside the input of g, that's exactly f. So yeah, well, that's just that's how we're gonna do this kind of problem. So that's good enough. Okay, so that's example 10. So for homework, this section, as you can see, the problems are mostly quite short, and it should be not so time consuming as some of the earlier sections. So please do problems 7, 13, 17, 19, 21, 25, 27, 31, 35, 39, 43, 47, 51, 55, 59, 63, 67, 71, 75, 81, 85, 89, and 93. That sounds like a lot of problems, but I feel that it's necessary, and they are all very short. Nearly all of them are very short, so you shouldn't take too long doing them, even though it took me a long time to read them out. So please go do your homework, and when you come back, I want to talk about some of them. So now let's look at problem 17. We have f of x is 1 over x minus 4, and then g of x is 2 over x plus 4. And then we're going to find out what f of g is, and then g of f is. So let's start with f of g. F of g, as f circle g, is the same as f of g of x. Okay, where you stuff the g into the f input and see what comes out. So then we will do this, right? Is well, first we figure out what g is. G is that thing. Okay, so we'll write that down. This is f of 2x, 2 over x plus 4, and then all right. So that equals to. We'll take this whole thing and put it where x is. See, x is down here. So we write down this whole fraction, and write this whole thing will replace x. Okay, so 2 over x plus 4 right here. We'll put it in parentheses. We don't have to, but that makes it a little bit clearer. So this whole thing replaces x in the function f, and then minus 4. Okay, it says so. So that equals to this, and now we're left with just simplifying the fraction a little bit, which is if you have trouble with fractions, people do that a lot. Even when they're good at it, they soon forgot what they learned. So if you do forget it, just go back and review and refresh your memory. All right, so let's do this. This happens to have a plus 4 minus 4 in there, which is convenient. So this is just equal to 1 over 2 over x, okay? And when it comes to fractions, to divide is to invert and multiply. So this is the same as 1 times x over 2, and which is just x over 2, okay? And this is the f of g of x. So let me check the answer. Yep, I am right, okay? The answer is at the back of the book. I don't know if I mentioned that before, but that's, yeah, look in the back at around page 1000 or so, and that's where the answers are. Well, so this is just f of g, and the next step we have is to do g of f. So let's write that down as well. And the two may not be the same. Sometimes you luck out and they are the same, but a lot of times they're not. So let's that is of course writing this thing except in opposite order. So g of f of x. And I feel that this notation is easier to visualize. Okay, so then it tells you that you need to put f of x in the g input. So then f of x. So f of x is here. All right. So that equals the g of. Let's write down f of x. This thing right here. 1 over x minus 4. All right, and then that would be equal to. So that continuing, that equals to, what is g of x? Is 2 over whatever the input is plus 4. So we'll write it down, 2 over, what's the input? Is this entire object, okay? So it's 1 over x minus 4. Notice this division line is longer, okay, because it's originally it says 2 over whatever's down there. So there's a longer division. The fact that this is happened to be a fraction changes nothing. It's 2 divided by everything that's down here. So it's a longer division line than this. And then, so having said that, keep going, is 2 over the input, okay, plus 4 over here. And then, so the next step is we got to work on that rational, it's called rational expression. And to do that, in this case, to divide by a fraction is to invert and multiply the fraction, I mean. So we have 2 times, invert this thing, it becomes x minus 4 over 1. Well, you can just ignore the over 1. And then plus 4, okay? So that equals to 2x minus 8. And then plus 4, and so that should be equal to 2x minus 4. And that should be the answer for problem 17. Yeah, it is correct. Yay! It's always good that I do a lot of stuff that I didn't mess up. You know, always consider that very, very lucky. Okay, so next. So problem 21, we have f of x equal to the square root of 2 minus 4x. Is that right? That doesn't sound right. Let me see. Did I write it right? Yeah, it says 2 minus 4x, fine, nothing wrong with that. And then g of x is negative 3 over x, and we're supposed to calculate g of f of x. Now, as always, we rewrite this thing as g parentheses f of x, because that may help me see things better, okay, which is g of let's write down f of x right in here. What was f of x, that thing? Okay, let's copy that down. 2 minus 4x. Okay, and then so then we plug this thing into g. Okay, what does g do? G takes whatever input and put 3 on top and divide it. Okay, so that we'll write that down. So minus 3 divided by the input, which in this case is that thing, square root of 2 minus x, 4x. And that is our answer as to g of f of x. The next question is the domain of this thing. Well, the domain has 2 conditions. Number 1, the denominator cannot be 0, okay? And number 2, what's inside here has to be positive. And therefore, the both conditions together means that 2 minus 4x need to be bigger than 0. It cannot be equal to 0 because it's in the denominator. So, but as long as it's bigger than 0, everything should look peachy. Okay, so let's do that math. That will be 2 bigger than 4x. If you push 4x to the other side of the inequality, which solves just like equality except for dividing or multiplying negative numbers. So I pushed it over there. Now it's positive. I don't have to worry about dividing negative numbers. So let's divide by positive 4. And that becomes 1/2. And so as long as x is less than 1/2, that should be the answer. Now in the set notation, in the interval notation your book wants, we have, this reads x is less than 1/2, right? So we'll draw the parentheses. What is that? 1/2, okay? And all the way to negative infinity, comma. And that should be good enough. So that says exactly that, which is x is less than 1/2. So let's look at the answer. 21, first one, yep, that looks right. And the second part of the answer, domain negative infinity to positive 1/2, that's correct. So this problem is right. Okay, next, let's look at problem 39, where h of x is 1 over that thing, and we're supposed to come up with 2 functions where h is the composite of those 2 functions. Well, then let's call g of x what's on the bottom, okay? X, what am I doing? Okay, so g of x equal to x minus 2 cubed. And then let's call f of x equal to 1 over x. That way, if you have composite f of g of x, then you can see quickly that that has to be equal to 1 over stuff g of x in here, okay, into f. Then you have x minus 2 cubed. Yeah, which is h of x, see? So that is a quick answer. Next, let's look at problem 47, where we have, we're supposed to judge from the graph f of 4. That just means we're going to do it 2 times. Okay, first let's figure out what f of 4 is. F of 4, if you look over there, when x is 4, y, is this f? Let me see, is this even f, or do they have a g in here? That might be, yeah, that's g. So f is on the other page. Okay, so let's flip to the other page and look for f. Okay, f of 4, as you can see, f of 4 is 0. Okay, when x value is 4, the graph says 0. So f of 4 is 0. Then it wants you to do it again. What is f of 4? So f of 4 is 0. We put it in the 0 and calculate what f of 0 is. So f of 0 then is equal to, well, according to this graph of f, okay, f of 0 is 4. So the answer is 4, which is correct. So next, let's consider problem 63, where we're supposed to calculate f of f1. Okay, there's the problem in the bottom there. So first, let's calculate f of 1. f of 1, according to the chart, is 6. See, it says right there. But we have to put the 6 in there, okay, and calculate f of 6. f of 6 then is 2. Okay, so problem 63, the answer is 2, and it is. So next, problem 93, we have some rain is dropping into a lake, okay, which creates a ripple. This R stands for radius. The radius of a ripple is follows this formula according to time. Okay, as time goes on, the ripple gets bigger and bigger. So then, so what are we trying to do? First, we need to figure out the area of the ripple. The area of the ripple, which is a perfect circle, okay, is the area of any circle is called pi r squared. Please memorize this formula if you haven't done so already. Okay, the area of circle is pi r squared. In our case, it will be equal to pi times r squared, is that thing squared. Okay, so I'll write this all thing down, 25 square root blah 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 plus 2, okay, and the whole thing squared equals to pi 25 squared, and then this thing the square root got canceled out, so that's good, t plus 2, and that will be the area at any given time. In other words, if you were to figure out 1 second, okay, you plug in 1 here, multiply this out, that's your area at 1 second. The book wants us to figure out the area at 2 seconds. Fine, let's plug in 2. So if area at 2, we'll write it this way. Area at 2 seconds equal to pi times 25 squared, which is 625, I think. And then times, what is that? 4, okay? And actually, we'll just write down 25 squared. And I think it's 625, but I'm not absolutely sure. Okay, but anyway, so this equal to 25 times 4 is 1,000. So this is, sorry, 25 times 4 is 100. Why did I say 1,000? I mean 100, right? Yeah. So this becomes 2,500 times pi, and that should be the answer to part 2. Yep, 2,500 pi. A lot of times we leave the pi in the answer instead of multiplying out in math problems. In physics or more importantly, engineering problems, they expect you to multiply the whole thing out. Okay, but either way, this is the right answer as your book says. So that is, well, that is this cute little problem of raindrops. Right. So that should be the end of this section.